Well, hello internets and my 24 subscribers. Now you're gonna see me get frustrated trying to adapt this microphone to the radio. Let's see. And you're gonna say, man, that's easy peasy, just get the schematic, get the pin out and you're all set. Well, not if you're dealing with this abomination of a schematic right here. Who did this was like trolling, hard trolling. First of all, the orientation of this plug is like sideways, and the pinout, the numbering is all over the place. At first sight, you would say that they just took pin 8 from here and just routed it to pin 8 on the plug, but that's not the case because pin 5 is like in a random position. If you're gonna look at this from the transceiver side, this would be like pin 1, this would be like 2, and so on. If you're gonna look at it from the back, this would be pin 1 and this would be pin 2 and so on. So this is unusable. I actually had to measure the plug on the radio, and I have here the way I would have drawn it. I don't know why they didn't do it like this. Just put the plug in the current orientation, number the pins like they are on the goddamn plug, and say that you're looking at it from the front of the transceiver, man. Yeah, I guess we will never know. um, yeah, so it looks like I have microphone input on pin 8, right? And I have a PTT on pin 7. Oh yes, and actually the pins on these plugs, I mean, pin 2, it's not the shielding, and pin, what is this one, it's not PTT. Actually, PTT, it's pin number 6 on the actual plug. So again, whoever draw this was a real troll, prankster, whatever you want to call it. Please don't. Probably this is like from 1990s, but man, why would you draw this? Okay, so PTT goes to pin 6, and then microphone goes to pin 8, and you have a ground on pin 1. Where is it? Pin 5. Pin 5 is the shield for the microphone. This one, PTT is on pin 7 grounding. But as these are like tied together here, you can use whatever. You can use either 7 or you can use either 5 for grouting. So there we have it. Properly drawn schematic. Right. You might think that you can just get a microphone and plug it in because it has the right socket type, but no. What happens if you actually, I don't know, put your speaker on this pin number, what this is, 5 pin number 5, and this is actually 5 volts. If you have a look at the schematic, this has 5 volts on it, right? To power up whatever C mic is. Carbon microphone actually, but yeah, again, not so happy. And what's really stupid, it's that in the JST 135 user manual, so the actual radio made for ham radio operators, it's right here on page 6. Look at this beautifully drawn schematic, man. What were they thinking, right? So this just happened to match our pinout. Like we have wait. Yeah, we have the microphone and the earth and the PTT and even the PTT earth here. Yeah, these are all okay. Not so much for the 9-volt part and up, down, and whatever, but yeah. Well, 1 week later, we have a few microphones. Well, actually, only two. And I bought some aviator cable with an 8-pin plug from AliExpress, but it only has like 6 wires and it doesn't have a shield. So yeah, other than that, the cable looks pretty new. It's a smaller diameter and more stiff than this microphone. This is an old Yaesu microphone. It's very old and very dirty, and I got it for like €5. This is the MH1B8 microphone. It's a 1990 something microphone, and it just so happens to have the same pinout that we need. So very nice. As long as I don't mess up with these buttons, which are tied to the 5-volt lines, we should be okay. Next we have the Uher microphone, the metal chunky one, which I'm going to cut this off, I think, because I don't need it. Maybe we'll keep it. And unfortunately for me, the most promising microphone, the one who had a someone PTT button, was broken, and I broke it even further, in the sense that this is now unusable. The coil here was one wire was down, so the whole coil broke. Maybe in a future project I would mount a coil for it, but I highly doubt it. Maybe we can adapt some, I don't know, condenser microphones for capsule cartridge for it in the future. I will keep this. I will keep the case. Right. I'm gonna try and use them with the Yaesu FTDX10 here. This is the Yaesu mic, and this is a condenser microphone. That means it runs off of 5 volts or something. All these are passive microphones, dynamic ones. They'll have a coil, and that's it. I'm gonna try to adapt something so I can plug it in the Yaesu. Why would I want to do that? Because well, Yaesu has all sort of, microphone gain thingy and stuff, while this one doesn't. For this one, you have to open it up and look inside just to set the mic gain, which kind of sucks. So the setup. Pay attention, internet, because the setup is complicated. I have a phone here that's running cool soft dual channel function generator, which is really nice if you want to generate like audio frequency stuff. And I have two tones. One it's 1.9 kilohertz and the other one is 700 hertz. Now don't ask me why I do this, I just read it on the internet. So yeah, this is outputting the both frequencies, but it's outputting one on this speaker and one on this speaker, and this is why I have it connected to an IKEA Bluetooth speaker. This is very nice. I just play output and this will be very loud for you or not. Right, so the output of this speaker goes to about 5 centimeters into the Yaesu microphone. I can then put the radio into transmit, not on Vox, but actually transmit. And then the radio is outputting something, and we can see the output on, what is this, the tiny spectrum analyzer, and we get about 88.2 or something on the highest peak. Right, the ARC sits about 7 with the stock Yaesu microphone. So this is the setup, right? Shut up. Okay, Now we're gonna do all the microphones and see if they are different. This is stock in terms of microphone settings. I haven't touched it yet, and we will also record speech on the computer here, and then we'll play that and see how the actual microphones, how they actually sound, right? So this is the setup. So that was the stock FTDX10 mic. Now we have this old SU microphone in the same setup. Let's put it on transmit. I just adapted the wire here in the socket. Let's see what we get. By the way, I'm using 5 watts of power, and with this we're getting about 87 dBm. 87, 85. The ALC sits about 5 and something, so we can say that this is a lower gain microphone. Okay, about focus, about 85, right? 85, 86 maybe. Great. And now we're gonna test the Uher microphone on the Sprache settings, that is voice settings. Putting this into transmit, and the ALC sits about 5.7 or 7 or something, and we get an 88.5 reading. Let's do another pass. So microphones are like same stuff. Let's try and put the mic into music. I don't know what we're gonna get. Well, now the ALC is a bit up. Oh, yeah, so ALC like 7, and we get still the same reading of about 88.5 dBs at the same spacing, even with the music setting. It's actually funny because the ALC goes a bit down when you put it on voice, and a bit up when you put it on music setting. So yeah, next I'll be using the SDR Uno software, so software defined radio, and record actually audio and video, and we're gonna compare how we sound.
Yankee Oscar 3 Uniform Delta Papa, outputting in a dummy load, testing Uher microphone on Sprache settings. Testing 1 2 3. Yankee Oscar 3 Uniform Delta Papa, outputting in a dummy load, testing Uher microphone on music settings. Testing 1 2 3. Yankee Oscar 3 Uniform Delta Papa, testing the stock FTDX10 microphone, outputting in a dummy load, testing 1 2 3. Yankee Oscar Free Uniform Delta Papa outputting in a dummy load, testing the old ESU microphone. Testing, testing, 1, 2, 3. And since this microphone has two settings, Yankee Oscar Free Uniform Delta Papa outputting in a dummy load, testing the same old ESU microphone. Testing, testing, 1, 2, 3.
And since I wanted to have a synthetic benchmark for all the microphones, I redid the test with the sound generator application, and this time outputting a sweep from 400 to 2400 hertz in the audio spectrum. And here you can see all the microphones doing their things nicely. I tried to kind of sync them, but yeah, I didn't do a really nice job at it. But all the microphones seem to have that kind of the same level, and the different settings on it, at least on the Uher, doesn't seem to do much. On the MH1B8, the old microphone, it has a distinct sound to it, but in here you can't actually see the, I don't know, the frequency, the curve or something. I think I don't know. I think for actually an accurate measurement, you could do like still an audio sweep, but I don't know, connect the output on the oscilloscope and do some kind of filter graph or audio response graph, something. But yeah, that's beyond testing for a simple microphone. Bottom line is they all sound the same to me, more or less. What can I say? Yeah, I'm not an audio guy. So there you have it. Adapting, frustrating, and testing microphones. Bye.